NCBM 0324, Section 1.3, Slope Formula and Graphing Linear Equations in Slope-Intercept Form, Part 5. Let's practice a few more of these graphs. So this is still example 4. We're going to graph in either way, whatever way we choose, either with mx plus b or with the table. But let's look at example 4c. Our equation is simply y is equal to 4. Y is equal to 4. So that's a special one. That one is telling me that I have no x value, right? There's no x in this equation at all. So if we look back at our notes before, we can recognize this as a horizontal line. And in a horizontal line, our m value is 0. So if I wanted to take this y equals 4 and write it in mx plus b form, and I can because I have the y equals over here, with the m of 0, this is like saying I have 0 as the m times x plus the 4. And I could use slope-intercept form now. I have slope of 0, so there's 0 rise over the run, right? I can apply that there. But let's think about this in the table format. This, I think, is a little bit maybe more manageable in some cases. So if I do the option 2, if I build a table, my equation is simply y equals 4, and I pick two x values. Again, it doesn't matter the x values. I'm going to pick negative 2, 4 in this case. So what this is telling me, if my x is negative 2, there's nowhere to plug in the x into my equation. Even if I use this version up here, negative 2 times the 0, well, that's going to cancel away. It's going to still be 0 plus the 4. All that's left is still the 4. This 4 from our equation. So I would be able to plot the point negative 2, comma 4. Well, what about my other x value that I chose? I chose a 4, just randomly. Again, is there anywhere to plug in that 4 into this equation? Is there any x in my equation where these are x values? Still no. So my y value is stuck at that 4. So no matter the x's that we choose, there's nowhere to change this number. I'm going to continue to be at 4. So when I go to plot, negative 2, 4 is over here. 4, 4 is here. Even if I had chose, let's say x was 1, the y value would still be at 4. Even over here, the y value would still be at 4. The horizontal line is telling me that that y value remains the same. So there is my horizontal line. All right. So again, sometimes a table shows us maybe a little bit more convincingly what's going to happen in the graph. Let's try this on D, because looking at example D now, my equation has changed. What's unique about this one, now I only have x is equal to 2. So now there's no y value in here at all, meaning I don't have slope-intercept form. If it's only an x value, then that tells me it's a vertical line. And vertical lines, remember, have their slope undefined. I can't use that mx plus b because there's no m to plug in at all. So in this case, the table really is the best way to go about it. So if I have x is equal to 2, and I have this y over here, in this case we're going to switch it around. I'm going to pick the y value, I don't know, maybe a negative 3 this time, and I don't know, positive 1. If I pick the y value, any y value, what's going to happen for this x? Is there anywhere for me to plug in the y into this equation, or any way for this x equals 2 to change with a y value? There's not. That x value remains the same. That x value is stuck at that 2. X has to always equal that 2. So plotting it and connecting with a straight line, we said that is in fact vertical. That x value is stuck at 2. Let's try one more example. Let's look at part E. We have 2x minus 7y is equal to 14. So what's different now about this example than all of our other ones in the section so far? Well, in this case, my y isn't isolated. I don't have y equals, I don't even have x equals. My x and y are mixed up within the left side of my equation. So in order for me to graph this using the slope-intercept form, and we can get away maybe with the table, but still will make it easier, is instead of reading and using the equation in this form, let's change it into that y equals mx plus b. And how do we do that? Well, we're going to do that by solving for the y. Let's get the y by itself. That's going to change it into the right form, and it's going to be easier to work with. So I have 2x minus 7y is equal to 14. I'm trying to get the y by itself, so I'm solving this equation for the y. Keep in mind we want y equals. So using my methods of solving linear equations, I'm going to subtract the part that does not have a y on it. So I'm going to subtract the 2x from both sides, leaving negative 7y, it's multiplied by y, is equal to negative 2x plus 14. And then we'll undo this multiplication of negative 7 by division. And when I do the division, remember I got to do it to both sides. And in fact, I got to do it to every part of both sides. So that means both pieces of the right-hand side are going to get divided by 7. On the left, this reduces down to a 1 times the y, so we have y is equal. And on the right, I'm going to have negative 2x divided by negative 7. Well, that's going to be positive 2/7 x. And then we have a plus 14 divided by negative 7. That gives me a negative 2. So there we have our m, our rise, and our run. Maybe even label it rise over run. I can move along my graph using that. And my b value is negative 2. So I'm going to plot the point 0, negative 2 to get my graph going. So 0, negative 2. Using my rise and my run, I'm going to go up 2 units and then to the right because it's positive 7. 1, 2, 3, 4, 5, 6, 7. Just at the end of my plane. Connect it with a straight line. I have my graph. I could have made a table if that was my preferred method. Either way, we end up with the same picture. Might plot different points, but overall, the image will be the same. To summarize the section overall, think of linear equations being attached to slope. The idea of slope is where the equations are built off of, and that's how we can interpret these graphs and get these graphs in a bunch of different ways. So slope equals rise over run, slope-intercept form, y equals mx plus b. We have those special cases of horizontal and vertical lines, and it's all important for the idea of linear equations.